Hey everybody, this is Bodechon here. So today we're going to be learning all about nuclear decay. What I'm going to be doing is I'm assigning alpha, beta, and gamma rays to a particular Avengers villain. So let's go ahead and look at this. Now we have three different types of decay we're going to be talking about: alpha, beta, and gamma. And so the lineup here from the least to the most penetrating power, that's what we're going to go by for today in terms of assigning which Avengers villain goes with which one. So alpha has the lowest penetrating power, beta would be second, and then gamma has the highest penetrating power. Now I'm assigning them based off of the skills, like the fighting skills that these Avengers villains have, any superpowers that they may possess, or any magical like staffs or gloves or stones or anything that they have that make themselves a little bit more powerful and a little bit more hard to take down than the rest of the villains. So let's go ahead and uncover what I have chosen for Alpha Decay. Alpha Particle goes to Killmonger from Black Panther. He has some awesome fighting skills, and he actually does take down Black Panther in the very beginning of the movie, so that's why I chose him. So let's get into Alpha Decay, shall we? So we can write alpha decay particles in two different ways. You can write them this way right here with an A representing the alpha. Now they have two numbers next to them. You need to know what those numbers are. The top number here, 4, is representing the atomic mass. And the bottom number, these are both written in either superscript or subscript, okay? And the bottom number is going to be the atomic number. So in this case, if you're looking at it and you're like, hey, if the atomic number is 2 on the periodic table, that's helium, right? And helium does have an atomic mass of 4. So basically, an alpha particle is really just helium, which is why we can also write this with an HE representing the element helium with the 4 and the 2 just the same. So these are pretty much interchangeable when you're writing your nuclear decay equations out, okay? So what does this look like with an atom, right, or a nucleus? If we have a large unstable nucleus and it's going to undergo alpha decay, it's going to become a little bit more stable each time it shoots out an alpha particle. Now the alpha particle you can see here is going to be 2 protons and 2 neutrons. So this is going to constantly get smaller and smaller as it undergoes that alpha decay until it has gone through the half-life process and decayed all the way. And you can check that out in my other video about half-life in order to know more information about that. But let's see about penetrating power. So we said alpha is the least of the penetrating power. In fact, it's so easy to stop. It can even be stopped with just a thin sheet of regular paper, okay? That is why I chose Killmonger. He does have some awesome fighting skills. However, he doesn't really possess any superpowers of his own, right? He has to steal the flowers and drink the liquid from the flowers in order to have any kind of super strength or ability whatsoever. So this is kind of just his own skills that he's learned throughout his life. So that is why I chose Killmonger as Alpha Decay. Let's see who is up for Beta Decay. Beta Decay goes to Loki from Thor. He has an abundance of superpowers and fighting skills. Plus, he can go toe-to-toe with the Lord of Thunder and come out not with a scratch on him. Alright, so let's go more in depth in Beta Decay. So we're first going to look at how we write it. So we're going to start with an E, and the E is really representing electron. Okay, that's how we're going to represent beta. You can go ahead and you can write this fancy B for beta as well, but our numbers are going to be the same no matter which symbol you choose to write. The top number is going to be the mass, and a beta decay is really just an electron. So the mass of an electron, you guys remember, is so teeny tiny that we call it 0, okay? So we're going to go ahead and write 0 as our superscript. Now that subscript on the bottom is representing our atomic number. An atomic number for an electron, it doesn't have protons, right? It's just an electron. It's negatively 1 charge. So that is what we're going to go ahead and write -1 at the bottom. And you can use either one of these when you're writing your nuclear decay reactions. So let's go ahead and look at an example, because Beta decay is sort of funky, right? It's going to have a neutron that splits into a proton and an electron. And that's like, what? What just happened? So let's step through this, okay? An example is carbon-14. So this is an isotope of carbon. And this one has 6 protons and 8 neutrons. When it undergoes beta decay, it will shoot out a beta particle. But in order to shoot out an electron like that, it's going to take one of its neutrons. So it has 8. So that 8th electron is going to be transformed into a proton, and it's going to kick out that beta particle as an electron. Okay? So from one neutron, we're going to get a proton and a beta decay of that electron. All right? So that's where it's going to come from. It's going to come from that one neutron. So we end up having started with carbon-14, but we changed our number of protons, and that's what identifies our element. So we had 6 proton, which is carbon, but we added 1. So because we add 1, we have to move up 1 on the periodic table. So now we're at number 7, which is nitrogen, and we're going to be nitrogen-14. The mass has not changed because a neutron and a proton both have 1 AMU, and we're just switching from a neutron to a proton. So it actually doesn't affect our mass. It just affects what element it is. Okay, so it's going to move 1 up on the periodic table, and it's going to kick out that electron. Let's go ahead and talk about the penetrating power. So it has a very medium penetrating power. We can stop this with something like a sheet of aluminum foil. Okay, I chose Loki for this, you guys, because he's a pretty heavy hitter, right? When it comes to the Avengers villains, he has all these superpowers. He has great fighting skills. He can like reappear and appear in different spots. He can multiply himself. He's like the king of illusions, right? He can totally trick you about where he's at and get you from behind. He also lies really well. Okay, so he has all these really, really cool skills when it comes to beating people in a fight, right? But he's just medium. Everybody ends up loving Loki at the end. At least I did. Did you guys love Loki at the end? Like when he died, did it break you up inside? You're just like, oh my gosh, Loki died, right? Because you end up loving Loki towards the end of the Avengers. Leave it in the comments for me. Did you love Loki as much as I did? Because I ended up really having a hard time with Loki dying. I thought for sure he was going to come back to life, and I was so sad when he didn't. So leave it in the comments. I want to see what y'all are thinking too. All right, let's see who our Gamma Decay is. I bet you can guess it. So you guessed it. Thanos is going to be representing our gamma ray because he is the biggest, baddest villain from the Avengers. It's the one that they have to fight in Endgame. He's the one that possesses the most power. All right, so let's talk about gamma decay. First up, gamma is a ray or wave. So this is the first one that's not a particle. Alpha, beta, they were both particles or pieces of matter. Gamma is actually energy, okay? So I need you to look at this in a totally different perspective now. So if you see here, we have our symbol for a gamma, and we have a 0 and a 0. Remember, this is representing our mass and our atomic number or charge, and this is a wave. This is a piece of energy. There's no matter here. There's no particles, so it cannot contain any mass, right? And it doesn't have any kind of charge to it. So when we're doing this, it's going to be 0, 0, which makes our nuclear decay equations so easy to write, you guys. This is definitely the easiest one. Everybody loves to get gamma, but I need you to understand what it really is. So when we start with an unstable nuclei, when it undergoes a gamma decay, it will become more and more stable the more it decays over time, but it's going to shoot out a ray or a wave, right, of energy. And that energy is, of course, radioactive, as all of these are, and it's going to be very powerful and can cause a lot of damage. So let's take a look at its penetrating power. So it's blocked by lead. Now, I know this is crazy because lead is pretty dense, right? And when we do this, we usually say 10 centimeters of solid lead can block most of it. So it's not going to block all of it. Hence, he says, I am inevitable, right? So it's going to still go through no matter what. That's why I chose Thanos. Not only is he the biggest and the baddest of all of the Avengers villains, but no matter what, he's gonna get through and he's gonna fight to the end. And so is Gamma. It's gonna go through even that solid block of lead. Some of it will still be getting through because it's just inevitable. Okay, so I hope this was helpful to you all, learning all about Alpha, Beta, and Gamma Decay. Thanks y'all for joining me. Hey you guys, if you made it all the way to the end, hit that like button for me. Subscribe to my channel to see all the new videos I'm posting on Science Explained. And I'll see y'all next time. Bye everybody.